Hello and welcome to episode 170 in this series where I am programming a game on the NES from scratch on Twitch. Let's get into the coding. So last time we got all our stuff working here with the export in terms of the maps. We were able to test that out on some real hardware as well as in the emulator. So the map, if we bring up tiled here, the map, it gets exported properly, colors are good, the enemies load properly, sure, whatever. And yeah, and so now this is looking good. So now the next part that we needed to do is we needed to look at the level data, because the level data right now is being written out, but the actual file, this assembly file, is not being written out by the export process. So we need to take care of that tonight. Did you know you put your Twitter account, not your Twitch account, for your stream announcement in the Discord right now? I posted my post from Twitter into Discord, is what I did. Oh, you know what? No. What? No, I posted the stream into Twitter, and then on the link to Twitter, it has the link to Twitch. Because I posted it into into Twitter, so people knew. So yeah, so this is the data. For each level, we have two possible export types. We have a standard map export, and then we have the repeat scroll, and then we have our null terminator. And then we also have the objects for each of these levels that needs to be included in here. This level 2 thing is garbage. Do we need these to be... I don't know. I don't think we need metatile palette table anymore. I do believe we need the sprite palette stuff. So what I'm going to do is, rather than trying to write that out every time, because we don't need to do that. Where is... So... Oh, I'm including it here. Why am I including it there? Realistically, I want all the include stuff all together. So let's do that. Let's just make sure, so this doesn't have, that doesn't have the segment defined. So that's going to be, that'll be part of the problem with some of these other files, I think. Why? How did I forget that one there? Segment code 0. So let's just make sure that all of these have the segment code 0 in them so that they don't have to be placed like I had them before. I don't know if anybody has been paying attention to the Game Awards at all. More interested in it because of the announcements, although they've been pretty uneventful so far. Hoping there's going to be something good, like Zelda related, for the 35th anniversary. Would be cool. Player collision. Oh, that needs to be... We'll fix that in a second. That's auto-generated. So it needs to include that in the auto-generated code. Okay. That's all looking correct. Okay, collisions are working great. So that's all good. Let's see. So let's look for a player collision. Can't spell. This should say segment code 0 in it. With the new line. Okay. So then the other thing that we need to do is we have this level data file. I want to include something I'm going to call level constants. .asm. Okay, so for that, I'm going to take this stuff, because this is stuff that's not going to change. Oops. Ah, darn it. I hit enter too quick. Level constants.asm. All right, cool. So that should still compile or assemble or whatever you want to call it. Yep. So that's there. And then this is the part that we want to auto-generate now. Why is my Twitch exploding? Because of Game Awards announcements. Okay. I'm going to turn my phone over so I don't see that, because I'm going to get distracted. Hope everybody's having a good evening. And I'm looking forward to Friday and the weekend. So let's see here. In export map, we load the map. Does it have, do we know what the map type is? We do. We're passing it in here. So it's getting it from the definition that's in the main build file. So it says it's a map, and that's called map1.json. And if we look at that and the level data, here, can I side by side that? Yeah. Let me close that for a second. What do we need to do? We need to know how many maps there are. We need to split the maps into the high and low bytes, and then actually have the export. And in here, we have a name. That's the full descriptive name. I probably want to do like a short name for the assembly code, because you know, just to kind of keep it straightforward in the code. Or do I want to do it by a numeric thing where it doesn't take in, where you can't define what it is at all? I don't know what would be more useful. I could anticipate where we might need it to use like intermediate maps for some reason. So I'm gonna going to stick with using short name as the property here. So we'll use that to generate this, and then this will break it up into low and high bytes, and then this is where we want to get started with the exports. So I need the short name. Final references should just be this. Okay. So we are iterating through now. The map file name, map type. Where's the map info type? Okay. Where do we do that? Loads. That's in load project. Where is the deck passed in? Maps info. So we're just going through the JSON and pulling apart the info here. So string copy s to info short name, max file folder name, iterator extract standard string, short name, convert that to a string, and that's it, right? Or does it need a max path to? Yeah. Okay, so what don't you like about this? It's the iterator extract. Maybe I need to no instance of function template. What are you talking about? I'm using it over here, but that's the beginning. Iter extract. Object layout element. Oh, sorry. Yeah. Just looking at the wrong thing. Okay. So that'll get our short name here into that type. So let's go back to where load project is called. So now we have the short name for the map, and we're going to iterate through that here. We have the map type being passed in. I just wonder if it makes more sense to just pass the map info type to export map instead of doing it like this. Just because, like, this way we don't have to worry about it changing or needing to add additional things or whatever the case may be. So this is going to be broken now. What we want to do is we want to say iterator. All right, so then export map. This is going to have a problem because of that change we made. And that will be, so what is it? Map info, map file name, map info, map file name, map file. Another one? Jeez. I used that more than I thought. Line map, character pointer is a character array. It's a const character pointer. Well, it should be a const character, I guess. Anyway. And then there's that. We have a few places where we are going to have this problem. I'm surprised it's only showing 2 at a time. Okay. That might be a setting or something. It's not really critical. Although it is annoying that I can't just see all of them. Okay, so now we have this loop where we've exported the map, and now we want to export the level data. So let's see, what we can do is let's create the file that we're going to export. What does it take as a parameter? I don't remember. Text file handle. Okay. What's the matter with that? Oh, it's just a... It's just a file pointer. Okay. No. Okay, so we're just going to bomb out there if we can't create the file for some reason, so we don't have the same kind of problem we had before with files that we thought we were creating, but we were not. And so what I want to do is I want to use the short names here for this define. This part is just pretty much constant. So segment code 0. It occurs to me that at some point that may not be true, but that's okay for now. So then what we want to do here is we want to have our dot define maps, and then we're going to have a space, and then we're going to actually start outputting the short names. So if iter +1 does not equal map files full path to end, we need to write a comma. We still want to write the short file name here. is kind of jank, but it's all right. So yeah, so write text. We just want the short file name. So iter short name. And then, oh, I don't need the star. So we're going to write the short name, and then we're going to write a comma if we need to. Otherwise, we're not going to because we're done. And then once that's completed, I'm going to write our new line. And then we're going to write this maps high, maps low part. New line tab. I guess it is a tab, isn't it? I don't want it to be a tab. I want it to be spaces. So we're just writing this literally out as you would normally. Although, now that I'm thinking about this, the ordering is a little bit janky. I guess it doesn't really matter if we... The order doesn't matter, I don't think. Let's see. Matters for me in terms of writing it, but it doesn't matter for the actual assembling of the code. So we will do our short name, long name, sorry, our list and stuff at the bottom. And instead of writing it out, you know what, that's okay. We can do that with this. I'll iterate again over it and write that out here at the bottom instead of writing it like this, because, like I said, the order that it's defined in doesn't matter, but we need to define, we're going to be iterating through the map anyway here. Actually, could we do it in between? No. No, we can't. Okay. So I just want to do it in this order because the list, the comma separated list, obviously the order matters there, but for this stuff here, while the order matters in terms of defining the actual data, this being after or before this stuff doesn't matter. That's what I was getting at before. Sorry if that was confusing. All right, so for a standard map, we said it's 1. Is that the same? I think it is. Let's see. Map type is a map type, or an enum. Let's make these match numerically with the code in the game. All right, so that's been defined there. So we don't need to. So we need to create a label for the level short name. We'll add an extra new line here for readability. And this is going to be short name I'm being pretty lazy about how we're doing this because I'm doing it in like dribs and drabs. Like realistically, we could get away with. We could probably do this a little bit more cleanly by writing this out in a buffer first, and then writing the buffer to the file. But I think it's okay. We should be all right. So that gives us that with our new line, and then we're going to start exporting the actual data. So we want to start with the type. And well, now we need an actual buffer because we need to convert the value. All right, fine, we need a buffer. So this will be a little bit easier to follow than the way we were writing it out in bits and pieces. So this will be level 1 colon new line 4 spaces byte, whatever the byte value is, new line 4 spaces high bytes. So let's look at this here. So we're going to name these things based off of what the file names are for the, based on like this map name that's used. So that includes the high and low bytes for the level objects, like where the enemies are. So we will need to construct that name here, but we'll do that in a second. And then this is the actual map data, which again, we've got to construct that name here. And we will then add 2 new lines so that we have some space between each map export piece or level export piece. So this is iterator short name, and then we're going to cast the map type. Oops. Map type to an integer, which it is anyway. It's just we deal with it not as an integer, as an enum in C++, and then we don't have the object data, so we'll call that object name and then map name. And then that's it. We don't have anything else to export there. So object name, and map name, or actually it would be map binary name, really, because we have the exported map from tiled, but this is like the exported from the NES Asset Tool exported data. So let's see what we're doing here. We're going to string copy to object name, iterator map file name. And then we're going to replace the file extension with, you know, well, that only works for the, let's do this. I would prefer some consistency here, so what we can do is we're going to change up the way we're naming the enemy file a little bit. So instead of being map1 or obj.bin, it's just going to be whatever the file name is .obj, which is a slight change up from how we're doing it now. It's just a renaming. It really doesn't do anything other than that. But then we don't have to do any other file name manipulation. We can just say .obj or .bin gets replaced, I think. Okay, you do need the dot there. So that should be that. Then we define the maps and we iterate through. We add the list of maps to it. And like level 1, level 2, whatever we end up having. And we have our maps high and low. And that's this. And then we're done. System hooks, close, text file, level data. I think that's good. The only thing we're not adding that we need to is the header. Where did we include file header? That's it. Just a little thing so that it's clear that this is a generated file and not something that we actually wrote by hand. Yeah, that should be a pointer. Oh, that return has to return something, some sort of numeric value. All right. I think this will probably get us what we need. Let's see. Nope, it'll get us a crash. That's what it'll get us. All right, let's run it in the debugger. Probably just a silly mistake here. Empty value. What is your problem? Short name. Oh, did I only add? That's for the levels. Did I get it in the wrong thing? Layout. Oh, yeah, I don't want it in the layout. That was dumb. Where is the actual level? Oh, it's right here. That's what I get for not paying attention. Oh, I guess I can do it. I can still do it in here. The map info structure isn't available, so that's why it was complaining about that copy. Okay. Come on. What? Thrown reading. Okay. What happened? What's no good? Iterator. It's got a pointer for that thing. It's a standard map. Reading access violation. Element iterator. it takes a constant map info reference. What am I missing? The issue is with the iterator, but well, maybe. That's what it seems like. Oh, wait a minute. I just saw a warning. Error list. Output. There's a warning, I think, about this, that I don't have enough parameters. Oh yeah, because object name happens twice before the map binary name. Okay. Yeah, that should be a string. There's another bug that it was pointing out in the warning. Okay. Anyway, that's not that important for what we're doing right now, but I figured I saw it, should fix it. It's pretty simple to do. Okay. Let's take a look at what happened. So, map1.bin, map1.object, that's good. I think I saw that it exported. Yeah, so level data.asm got exported to this here. Oh, right. So I'm putting together the string, but I don't actually write it to the file. Guess that probably would help. Oops. Except you have to, you know, tell it what file you're actually writing to. And not make typos. I'll fix the fact that it's not writing to the right folder in a second, but let's take a look at what this actually looks like compared to the hand created one. So we have byte 1. We'll fix that in a second because it's not doing it as a hex, but it's not really that big a deal. High bytes is, this is wrong because we just want the file name. This is same problem. And then ink bin, this can be the full path, that's okay. Although I think I'd prefer that it isn't, so it's not pulling from a different directory. And then the rest of this stuff is okay. So let's take a look here. We've got too many spaces for low bytes and ink bin. Guess I could, okay, so that would fix those. And then I'm pretty sure I've got something that'll just give me the file name only. Get file name. So this is object name. I'm just extracting just the file name out of it because I don't want the path to be included. Oh, actually, now that I'm looking at this, we're also not including the bin file, which that's okay. I can fix that, but I don't think you can have a period in the label, can you? Let's see, I don't think it's going to like this. Yeah. Yep, didn't like that. Okay. I didn't think it would. So that's going to be another problem with this. So we need to... I think I can do that. I think I can tell it to replace the extension with an extension that doesn't have the dot. Pretty sure that's not even the right place. Replace file extension. Okay, so max size, remove the file extension. Oh yeah, so that'll totally work. It'll remove the extension and then we're good. So that's good. That'll get rid of that, which is what we want for this first part that we're writing this out, because the dot doesn't work. Here's our binary file. Let's just take a look at what that looks like now. Okay, so map one object, map one object, ink bin. Oh, I need to, for map binary name, I need to, oh, do that. What happened? How come? What happened? It didn't crash. Map file name to map bin name. Get file name into map bin name. Replace file extension with .bin. That's weird. Oh, it was just not reloading it for some reason. Okay. So... oh, I didn't fix the... I mean, it doesn't technically matter if we use binary or decimal for the byte. We just have to be consistent. I'm going to use hex just because... Well, actually, I don't care. That's really not that big a deal. Alright, I'm just going to leave it. That's fine. Do I want to put the comments in? I probably should. Just for my own sanity. But that's going to mess with my string here. We'll still do it. Oh, but then the formatting is going to be messed up depending on number of digits. Okay, I'm not going to do it here just because I don't want it to be a problem. We're gonna write some like documentation out into the file just as a way to remind me moving forward, but it's not going to be actually in. It's not going to be in line with the data, just for the sake of keeping things simple here. So similar to how we have the include file header, we'll have something called include map doc. We'll just write that out. So after the high and low bytes, then, depending on what kind of map it is, it has different data. So new line, and we'll say if it's, oops, if it's a standard map, then the map data follows. If it's a repeat scrolling map, it is 2 bytes for the Y world camera, well, what the camera Y world position starting point. 2 bytes for the meta tiles used, meta tiles to be used in repeating background generation, something like that. That's probably good enough to describe what's going on there. Oh. Let's take a look. Okay. Oh, we're missing a new line here, and that's good enough. Okay, cool. So let's add a couple new lines, and it exported. Now it's good. Okay, so we have our level 1 map 1 object, low bytes map 1 object, include binary for map1.bin, and then maps level 1, maps high, maps low, and the only other thing we're missing is the actual map1 object.bin being defined and included. So where do we want to do that? I guess we could do it right after the level itself. Oh no, we can't, because why? Because we need the sections of the level to be contiguous, but that's for the full level. The short name has that. Oh, it gets it in each one. It's actually not. So this is really the map section. It's not like the whole level. Like in the JSON file, we have an array of these levels, and then they're made up of this layout. And that's what this map info is. It's really the layout rather than the whole level. So there's like this wrapping structure around it that we don't have. But it's really just really just like a list of map info lists, except for there is some detail there. So we can do just creating this thing to encapsulate the actual level. So short name should really be part of this. And then we can include the name. I guess we could just do, yeah, so the name is short name and the scroll speed. All right, so now we're gonna have stuff that's broken because short name doesn't exist here, but it does over here. So what we really want to do is we have this load project thing that's getting right now this list of map infos. We want it to take this. No. Oops. Okay. So that's level info. So now the map info is obviously not going to be here in the code that's processing this. So level info. It's the same kind of thing as below it. We're just taking what gets passed. Why? Oh, I named it the same thing. Sorry. I named it the same thing as what we're naming the variable we're extracting the data out of, the actual JSON, and so that's why it was complaining. So we're iterating through that. So we have levels info. So for level info, what we want to do is we want to level info scroll speed. We don't use this right now, but get value uint 8 scroll speed. Right, so we're just populating that, and then this is a string copy. So we're copying our string value out of this, so we'll have the name too, and then we've got to do that for the short name, because the short name is part of the level, not the layout section. All right, so then we actually get the layout array and hope that that actually has something in it. And if it does, we go through and iterate and pull the pieces out. And then what we need to do is, oh, so we don't do this multiple times here, which we should. So if, not if, for Auto iterator is that. Iterator does not equal layout dot end. And I remember that when I wrote this previously, I was saying, you know, the fact that we're not iterating over it is a problem. Level info dot layout dot pushback. So we're pushing the segment into the level info list of layouts, and then once we're done with that, we have our levels, our level list, and we're just going to push the level info struct into that. So that's going to give us our list of levels with our layout sections, which is what we're actually exporting each time. So now any place that calls that is going to be broken here, and that's fine. We want to change this to standard dex level info levels, and we're going to pass this, so that's going to give us all of our levels. And then when we come down here, this is going to be broken now because we're not iterating through the levels the way we should be, but that's fine. So what we will do is we will have a level iterator level iterator does not equal levels dot end plus level iterator, and this all goes into that. This goes to the end of the process of iterating through the levels. And then we want to call this it's not a great name for it, but it is, yeah, let's rename it, but we're just going to take this thing here. This is a reference. And we're gonna assign it the value of level. No, sorry. Is that the whole list of? That is. Okay. Sorry. So that's going to be now what we want to operate on. So that gives us that. And then short name does not exist here. But let me look at this data for a second. This is the exported one. This is the exported one. Compare. Whatever. Just close it and reopen that again, please. So this is the original one. I want the label only needs to be written once for each layout. So this can actually go away. Well, that part can go away. And then iterator short name is no longer used because it's not even the right spot anymore. So move that to here, and then right into this buffer, the new label, and this is level iterator short name. So So that gives us that label, and then we're going to iterate through the sections of the map, exporting all the stuff that we need to export. And then once we're done with that, we will go back into here. And then this is the wrong thing we're iterating on, because like I said before, the actual thing we need to iterate on is the levels and not the layouts. So we're going to write out this with the short names again, and we have that. So that looks pretty good. And then the whole reason we were doing this process of changing this was because once this layout stuff is done, we need to, it's a little annoying. I wonder if we could save that up in a buffer somewhere and then just write it out at the end, because we need to write out each of these to include the object files for the enemies. So it has to be at the end because the order of this stuff does matter, because it's just the raw data basically. Yeah, so let's just create a buffer, a larger buffer for that stuff called object buffer. Although, you know, we could just cheat. Let's just cheat. Is that going to work the way I want it to? It's not. But the other way I wanted to do, I was going to just put it together in a list of strings and just output that whole thing. But if we do that, then we got to iterate. That's fine. That's fine. Let's just do that. Let's just get this over with. I want to get back to creating levels. I don't want to be monkeying around with this anymore. So let's do that. Let's get this over with. So we've got our object info stuff here. And after we write the text, what we're going to do is we're going to write the rest of the text into buffer, because we've written out what we needed to there. And what we're going to do then is we're going to take, we're going to say object name colon new line, and then we're going to write ink bin, and then we need the name of the file, and then once we have that, we're done, and we can new line twice. So the name of the file got kiboshed because we replaced the extension with just obj instead of .obj. So we're going to fix that here. And then we're going to pass object name to this. And that'll give us the information in the buffer. And then we'll just push that into here. And then now that that's done, this needs to be, oh, it is. It's on the outer part. So now that that's done, object info dot begin. And we're literally just going to write out these strings to the file, because we'll have processed, this is level 1. And then I guess we probably want to do that all the way at the end so that the level data is contiguous. All right, so that's a simple change. Let's do that right here. So we're going to do it outside of the actual level loop, which means that we just need to move this object info list here outside of that loop. So we're going to go through and we're just going to dump everything at the end here. So yeah, system hooks, right text. It is called level data, iterator, C string. And it's that simple because we're just dumping everything out into the file, and then we have this define maps thing, and then we're going to close the text file after we do this. I think that's good. And let's see what we end up with. Hopefully not a jumbled mess. Hopefully not a crash. Doesn't look like it crashed, so that's good. Where are you? Here. So we have no, so we're missing, so let's take stock. We're missing that, right? And then we have a repeat scroll here. That's good because that is in the definition. So that's good. I'm not sure why the label isn't there. And then we don't have our ink bin the way we're supposed to, but we have this. So we're pretty close. Let's start with the label. At the beginning of, oh, because we're just sprint effing it. You gotta actually write it out to the file if you want it in the file. Huge revelation. Okay, so that's the first part. And then ink bin, what did we do wrong? Oh, I got caught up in fighting the auto quoting nonsense that it was doing and forgot to put in the %s to actually write the file name out. So, oops, so that is that. Doesn't want to reload the file. Okay, fine. Here. So, byte 1, map1 object, map1 object, map1.bin. Ocean1 object, ocean1 object, ocean.bin. Here are the binary files that we're including. Oh, blast. I did this too soon. Because I need both the the name of the file. Okay, let's do this. We're going to sprintf this in here, and then we are going to string. No, I can't do string cat with that. I can do a string cat of. We're going to go this far, and then we're going to string concatenate. So this name is correct because this is the label name. We don't want the dot. But for the file we do, so we regenerate that with the dot. And then I want to string concatenate the newly generated object name, and then I've got a copy off. I gotta finish close the quote, and then add a new line, and that's that. So, and then this should be word name. I think that'll fix that now. Map1 object there, ink bin, map1 object, ink bin. Okay, cool. So that's fine. Now it should be doing this in the exports in the export folder instead of in the main assets folder. So let's fix that. Now there may be stuff that's broken with the export because it's actually exporting everything, including the repeat scroll, but that is probably okay. Let's see. We're just going to take everything in here. Level data.asm, let's just double check that one more time. Segment code 0, it's got the comment, it's got everything that it should. This is wrong because we know that it should be adding these bytes, but it doesn't have that information yet, so that's okay. We can add that shortly. We have this ink. You know what we can do? Just to eliminate this as a problem, we'll save that for now, and let's dump everything that's in here and re-export, and we got everything back. So level data.asm, I gotta reload that. Now we don't have that problem. I do want to add an additional new line to the file dump for this. I don't need to do it in a separate call. Just do that there. Just for readability. Okay, that looks good. We're just gonna go for it. So let's build this. No build errors, so that's promising. Let's reload the ROM. And that is working. And just to make sure that I did not cheat or anything like that, level data.asm is here. This is the auto-generated one. It doesn't have the additional repeat scroll stuff. Cool. So let's add this back because I want to see what that looks like with the data exported, if that breaks anything in any way. I know that the data is not right because ocean1 object.bin, shouldn't it just be ocean1.object, ocean1.bin? Oh, because it's repeat scroll, it's probably going down a different, slightly different path here. Object.bin. Object. Map data. Repeat scroll. Here are the map objects we're exporting. We're writing the data out. Why is this doing it differently than we have map1.object and map1.bin, and then we had ocean1.object, although that's from that's, I'm looking in the main project folder, not the export folder. That's why. We can get rid of that. Okay, so ocean1.object, there's no ocean1.bin. Let's see if that breaks anything. And we'll know that the issue was that, you know, we added the repeat scroll to the export process, and it was not happy about that for some reason. So again, we know that the byte information is missing there. We can fix that. Ocean1.bin. Oh, right. So it shouldn't do that if it's repeat scroll. Okay, cool. That makes sense so far. This is... yeah. So... So if it's a standard map, do this. Otherwise, there is no map data to export because it's a repeat scroll, so don't include this part of the data for export. And then that goes away. All right, so let's go back to this. Replace these files and go look at this. Okay, good. So it shouldn't complain about the missing binary file for the map level. And it does not. Let's make sure nothing is messed up here now. Okay, cool. So we know that once we get to the repeat scroll mode, it's going to be wrong because of the issues with the missing data for the camera position and the repeating tiles. So what we need to do is have something like camera start, and then add this copy here that I made when we started all of this, and it will give me the data for the camera position. It's E10, which is what? 3600, is that right? 10E0. That, yeah, E10, so 3600 is a good starting position. And what was the last thing? The last thing was the meta tiles to use. We'll just use the same kind of logic here. Although I can just do this now here, like that. All right. So this is cool. This is the info we need. We're not doing anything with it in the export process, but let's change that. And then we're basically done with this, I think. Let's see, map info. Called camera start. And then we'll just have literally 2 bytes for the tiles here. Just kind of keep it really simple. So here is our processing the level info again. So to get the camera position, we just want to say info.camera start is equal to layout element get value uint16 camera start. Right, so that just pulls that value out, and then the tiles are a little bit trickier because we have an array there. And we just just want to extract that out. Layout element, oh, sorry. Iterator, extract, object, pointer, and that gives us the tiles. Let me look at this here for a second. Oh no, we have that. What am I doing? Layout element, just get array. And then we want to extract it. Make sure it's not null for some reason. And it's basically the same process as before. Although this is such a basic thing. It's an array. I should be able to just get value. Can I do that? Trying to see if there's a way to do this without having to do any weird nonsense. Get element. Oh, I can do that. Does that, would that work? And then I can say get value. Get element gives me what? Whatever the type is, which is uint 16 or uint 8, really? Like that. And it's pretty dead simple just to, I just want to get those two elements. That's all there's going to be. If the array is there, it should just have those two. Hopefully that works. Nope. Cannot convert empty. Get value is not working. Camera start. Why? Layout element. Camera start. Oh, because it doesn't potentially have it if it's not a... Right, if it's not a repeat scroll, it's not going to have a camera start. All right, simple enough. Just check to see if it has it. If it does, we'll extract it. What we can do is put the breakpoint here so we only stop when we're actually looking at this. What does tile 0 have in it? Oh, what am I doing? Obviously, I'm just tired here, making a dumb mistake. Although that raises the question if I could do that. I guess not, because it didn't like when I did it. So info tiles 2 and 3, good, so that's right. And then camera start is 3600. Okay, cool. So all of that is there now. So in the latter part of the export process, the only part we're missing now is we need to export this as 2 bytes and then the other part as 2 bytes. So, and it is low byte first. So 100E. And that is after the low bytes, high bytes. And this is repeat scrolling. So we have byte. We're going to have %D. We'll do %X because we want that to be in hex. So that we'll have the $ and the value in hex. And then we have a new line and the 2 values for the tiles. So %X and $%X. So this should be relatively straightforward for the tiles. Let's do those first. We have tile 0 and tiles 1, right? Pretty basic. The only thing we probably want to do is just AND this value against 0xFF. And the reason for that is I've seen cases where, for whatever reason, I think it assumes it's a 32-bit value, and so you end up with some garbage in the value. So we're just going to mask out everything that isn't the first byte because we don't care about anything else. And then, so similarly with this camera start, this is a 16-bit value, but we do actually care about doing some manipulation to this. So what did I say? The first byte is the low order byte. So we're going to do an AND with OXFF, and that's going to be fine. The trickier one is going to be the second one, where we're going to AND against FF00 because we want the upper 8 bits of the 16 bits, and then we need to shift that down because we are writing out just whatever the value is. So normally we would write this out as, like, you know, in C it's like it's 0E10. So we're going to mask out the 10, make that 0. Actually, we don't even care about that, do we? Yeah, we should do that because of the problem I said from before, and then we're going to shift it down so that we just get 0E. All right, so, and then we're going to shift it by 8. We're shifting a whole byte down. So let's see if I did that right. I assume it's in the export folder now. Let's see. Okay, so we have a problem with a missing new line. Why is that just 1, 0, 1, and 1? Too many spaces also. Because apparently I can't count. All right, so the camera start should just be 3600. Let's take a look at this. Hey, Johnny. It's going pretty good. We're just wrapping up, I think, this export stuff so we can get back to the level design. So that we don't have to be manipulating this stuff by hand. Camera start. So that's... what is... Camera start is 3600. So 3600 by that. Oh, no, I'm just a dummy. I'm talking and I'm trying to do bitwise operations, and I'm doing logical operations because I have two ands, two ampersands instead of just the one, which is why we just got ones and zeros, because it was saying true, and that is complete nonsense because it has nothing to do with anything we're actually doing. So That was ridiculous. So let me reopen that. E10 now. And then we still have this problem with the new line, but we have 2 and 3. Okay. Great. So need to add the new lines back. So can you make arrays with assembly? Let's talk about that in a second here when I look at this file. And we'll talk about what that actually means. All right, cool. That's good. The only thing I don't like about what it's doing there is it is not putting an extra space. And I'd prefer there to be an extra space between the object exports. So if we look at the file now, oops, hopefully Windows was shuffling things around, so it thought I was trying to double click the character file. Come on. Okay, good. So we've got spaces here now. So that's the level, that's the 2 sections, that's the objects, that's the stuff there. Okay, cool. So we should be able to just now dump this into here and replace everything. Rebuild. And restart the game. And things should be happy still. Okay, great. They are still happy. Let's see if we can fast forward till we get to the enemy area. We should be able to get to the repeat scrolling and actually have that work. Let's see if we can do that. All right, I got killed. So it is repeat scrolling, but something else is wrong because of the placement of that. We'll have to look at that. I'm not sure if it's the data that's wrong or if it's the... Oh, it could be the Ocean 1 objects. I mean, the repeat, it's definitely doing what it thinks it should for repeat scrolling, but something's up with that. I'm not going to look at that tonight because we accomplished what I wanted to in terms of being able to export this. So this is being exported, but let's get to Johnny's question real quick here before we wrap about arrays. So the answer is yes, but with the caveat of the fact that assembly doesn't really know what an array is. And what I mean by that is if you look at arrays, like visually, when you refer to an array, you're drawing like this line with these dashes to indicate that there are multiple elements, right? Well, why is it represented like that? Well, because that's what it is in memory, right? Or that's what it used to be in memory. Now, when you deal with arrays and other list types in modern programming languages, it's usually not that simple at a core level. Somewhere in there is just a contiguous piece of memory, potentially, depending on what kind of list or array type it is. But in C or in C++, when you say, you're making an array of like, character, data, 256, right? All you're doing is you're telling the compiler, hey, we've got this whole bunch of memory here. I need you to allocate this section here of 256 bytes, right? to this thing called data. Well, okay, we'll get to that in a second. So that's even more complicated in some ways, but yes, it's possible to do. So when you look at the code that manipulates that, it's just going from address to address, right? It's going, as the index goes up, it's going to a location further down in memory. So the way that assembly handles that is it doesn't, is there a way to, I'll just do new. It doesn't know anything about array specifically, but you can tell the assembler that you want to create a label for something and reserve the bytes, right? So if you go to shooter.asm, you can see I have this thing, attribute buffer.res64. I'm just telling it, hey, reserve 64 bytes in RAM for me. When you're doing your assembly, when it does the assembly, it doesn't do anything special about that per se, other than when it's creating the addresses in RAM that these reside in, it knows that it should create force row load 64 bytes later in memory than attribute buffer, but that's all it does. After that, it's all basically up to your code. So your code needs to, when it's reading this, you're using the X or Y register to index into it. So X is essentially like your index into an array. I mean, that's literally what it is in this case, and that's why it's called an index register, because it allows you to iterate through the memory that is presumably allocated or set aside for this array of 64 bytes. Now, is there anything special that it does to handle that? No, it's like literally pretty dumb. So if the assembler decides that your array is at address 50, and then you want to iterate through it, right, to get to the fifth element. Great movie, by the way. Maybe a little bit weird and whatever, but I still love that movie. Anyway, so if you say load a 50, right, that address, you wouldn't necessarily write that in your code because that's like kind of hard to deal with, remembering all those addresses. So you'd say, you know, load a attribute, right? Or let's call it just array. If you want to get the fifth element, you have X. You use X to get that fifth element, and what you're doing is you're loading X in with the value 5, right? Sorry for my handwriting; it's pretty terrible. Let's just say load X 5, right? So what the assembler is doing is it's saying, hey, your thing array is at address 50 in RAM. You load X to, and then at runtime you're loading X with 5, and you're saying load a array X. So it's taking that 50, it's adding the value of X, which is 5, and you're getting address 55, right? That's all it's doing. It doesn't know that it's an array. It could be that this is a mistake in your code and you're indexing into memory that doesn't make sense because array didn't even reserve 5 bytes. You might have defined it to reserve only 2, and it'll happily do that because it has no idea what an array actually is. It just knows how to access memory and index through memory. RS versus res. Yeah, it just depends on the assembler. So yeah, it's just syntax in terms of telling the assembler how to, you know, which, how many bytes to set aside between all of the addresses it's creating for each of these labels. Because that's what these variables really are. They're just labels to help you give a name to a position in memory. There's nothing really special about them. It's not like in TypeScript or C++ or C Sharp, where these are like class instances that have methods or whatever. So now to your other question about 2D arrays, yeah, you can do that, but it's a little bit complex, because what you have to do is you have to say, okay, I've got this memory here, and in the memory, it's not really data. I'm setting aside 2 bytes at a time. We'll do this with a different color. I'm setting 2 bytes at a time aside for the address of the array that I'm trying to deal with, right? So these are addresses that I am interested in accessing, which will then each refer to a different chunk of memory, right? So it's totally doable. You can write code to access to do this, and to say, okay, you know, I want to manage the memory so that I can put the address in here, and then I know that, you know, I'm accessing this chunk, and then I put the address into here, and I'm accessing this chunk, and I put the address into here, and I'm accessing this chunk. But you can kind of see that like actually uses a lot more space. And I'm not saying that you don't need it. You might, but like I would think about why you think you need a 2-dimensional array to handle this stuff, because you're inherently, for every chunk of data that you're storing in RAM, you're inherently wasting 2 bytes of RAM to be able to look it up in this array. And yes, there's 2K of RAM on the NES, but you know, it could go fast if you're not careful. And it's also inherently less efficient to index through this way, because you have to iterate through this array 2 bytes at a time, then load the value that's in here into a 2-byte pointer variable, and then use, you know, something like load a pointer to actually get at the value, which is an inherently slower operation also. So yeah, I mean, just, it's totally doable, and there are ways to make it happen and write your code to make it work that way, but it's probably not the preferred way unless you have a very specific reason for needing it. I was thinking, like, for filling a screen with 2 types of tiles, where one you can walk on and one you can't. Oh, I see. So you'd have, so what, your array would keep track of like the 2 different types of tile lists? I mean, generally the simplest way I would say that this is that kind of thing is handled is, you know, you just have your array that forms your grid, and then, you know, you have your different tile values that you're using here. You know, you have 5 and 10 and whatever the case may be, and you have that available in memory or somewhere, like maybe you're reading it from the ROM, and just the value of the tile itself is like what tells you if you can walk on it or not. So if you're crossing over from 5 to 10 and 10 is not a walkable tile, it won't let you do that. But let's say that below here is 6 and 6 is walkable, then you can walk down. 0 would be open tiles and 1 would be bushes or whatever. Right, but like, so the way that that's normally done is like is that information is kind of encoded into. There are a couple of ways, but like the main thing would be to just encode that into the tile itself. And when I say encoded, I mean it's just like inherently, it's just inherently part of the definition of the tile, or you could do something where like all of your tile, you limit it yourself so that in your 8 bits, if I can draw a byte, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so if you have a byte like this, you can use the first 7 bits. So you don't use this high bit here. You use all these other bits for your tiles, and then this bit here, if it's set, means you can't walk on it. So instead of having 2 separate grids, one for whether or not you can walk on a space and then the other for the actual tile data, you ignore this in terms of like what tile I'm interested in. That's all just these 7 bits. And then this bit here is your walkable bit, where you say, if this bit is set, I can't, Link can't step on that bit. I don't know how it's done in Zelda itself. If Mira Lupa was here, I'm sure they know, because they seem to be pretty knowledgeable about Zelda. So that would be something to ask maybe next time. And so yeah, so that's a more efficient way to do it, because if you think about it, right, like then if you're going to do it the way you're describing, you've got 32 by 20, right? So you've got 960, I think is what that works out to be. I always forget, but I think that's right. 640, okay. 640 tiles. Oh, it should be 30. It should be 30, not 20. 32 by 20 is not correct. 32 by 30. Yeah, that's why I was saying 960. 32 by 30, right? So you'd have to do that times 2. So just for one screen, you're talking about almost 2K of data, where you could encode sort of similar amounts of data in just that one screen. It's kind of a weird shift, like, because if you think, like, with modern computers, that amount of memory we're talking about is kind of laughably small, so nobody really cares about that. But because you're dealing with the NES and you're dealing with processing time constraints and memory constraints, it does matter. You do want to kind of keep that in mind. So, all right, we're going to wrap it here. We've got the export working. The repeat scroll part of it is not working, but that's okay, because I have a feeling that it's something to do with maybe either this object binary for the level, because if I remember right, I don't think we actually fixed this. Like, this has too many tiles in it, and so I gotta fix that for the next time. We'll actually work on like level stuff finally, now that we have the export working properly, which is cool. I'm excited about that. So let's call it for today. As always, if you want to reach me, I'm on Twitter at Clervis. You can reach me on Video Game Sage as Zelius. I am on the Discord as Zelius and Video Game Sage, but also as Clervis everywhere else. You can email me at zelius@gmail.com. Feel free to comment in the comment section in the description below the video if you're watching this on YouTube. And have a great weekend and have a good night. Thanks very much.